Hello everyone. I hope you all are doing well. Welcome back to Intellect Insight. In today's video, we are going to develop a blockchain for transactional purposes. You can develop your own blockchain for your own use cases as well. Let's say if you belong to educational institutions, then in that case you can develop a blockchain which can store a data of your students, faculties and etc. If you belong to medical institutions, then you can store data of your patients as well. There are several applications as well. Now, before you start watching this video, I would highly recommend you to go and first watch my previous video on blockchain, so you can have a clear idea of what exactly terminologies which we are going to develop in this video, such as hash, previous hash, genesis block, all, what exactly it means. Okay, so without wasting any further time, let's start this video. So for this video I've used IDE, which is Visual Studio Code. I've created simple file. You can create one like this. You can click here, blockchain.js, and in order to create a hash for each individual block, first we need one library which we are going to import it from this thing, npm install. You can write it like this. If you don't have npm install in your laptop, then don't worry, I'm going to put link for npm how you can install in the descriptions. Okay, so you can get it from there. So npm install, then crypto-js like this. So here you can see node_module, crypto-js, all of the files has been imported, and here in package.json you can see the version of crypto-js, which is 4.2.0. okay, so now we have everything what we need, so we can start. So first we will import SHA-256 from crypto-js, the library which we have installed recently. We are going to import that. So how you can do that? Const SHA-256 is equal to require, this is how we import, right? crypto-js slash SHA-256 like this. Done. Now we have SHA-256 which can be useful for creating hash value for each individual block. Now we use this to create a unique fingerprint called a hash for each block. Think of it like sealing the block so no one can change it, right? Now second step would be the block class, like what exactly block has the information. Now we are going to define a block class because we need to tell the program that what exactly each block stores, right? So define the block class. Okay, so how you can do that? Class block, then we can create constructor. So when we instantiate this specific class, it will automatically initialize all of the variables which is there inside the constructor. Index, timestamp, then data, previous hash. Okay, previous hash is equal to like this and this. Okay, you probably wondering why I haven't put hash, because in the previous video I discussed about each block also has its own unique hash value known as digital signature as well, which we are going to see in a moment. Because every time we initialize the constructor, it will automatically calculate the hash value for that specific block. We are going to define that function soon, right? Okay, so now let's initialize all the parameters. So now let's initialize the parameters. So this dot index is equal to index. Okay, this dot timestamp is equal to timestamp. Then this dot data is equal to data. This dot previous hash is equal to previous hash, and this dot hash which I was talking few moments ago, this dot calculate, this dot hash is equal to this dot calculate hash, this dot calculate hash. This we are going to implement here within class block. So how you can implement this one? So this method will be for calculate the hash of the block. Okay, how we can implement? So same method name calculate this dot index. Like how you can do that? So index means 0 1 2. So this dot index, based on this parameters, it is going to create a unique hash value for each block. Before doing this, we will do return SHA-256, because this function, it's here, we have imported from that library. You can see here this one, okay, which we are using here. This dot index plus this dot timestamp plus json dot stringify, because in a specific format we need data, so you can read it, right? Because otherwise it will be in a value. This dot previous hash, right? And that dot to string, like this. Okay, I hope you are getting it. Now here we have created a class block, then this one, then each block stores index, a timestamp, data which you would like to store, the hash of previous block, and hash of current block which we are calculating here based on this specific library. That's it, right? Now let's move to create a blockchain class. Okay, so define the blockchain class. So how we can do that? So class blockchain, similar to class block. Now same as class block, we will create constructor as well, but in this constructor we are going to define like this dot chain is equal to this dot create genesis block, because every time this constructor will be called, this genesis block automatically called, and it will create that specific first block of the chain. Okay, so whenever you create instance of blockchain class, it will create a genesis block automatically because it is inside a constructor. Now let's create the first block in the chain, means this method. We are going to implement that, create genesis block. Okay, how you can do that? Return new block. First we will pass index, so it will be 0 because it's the genesis block, first block of a chain. Then right now the current date and time when data has been stored. Okay, then data itself, genesis block, we can simply write like this, and then 0 because it's the first block of the chain, so it has hash value 0 because there is no previous block. Okay, I hope you understanding. And let's say if you want to get latest block in the chain, then how you can do that? We are going to create method for that. So get latest block, right, like this. Now return, what it will return? So this dot chain, like this specific chain, you are going to get length of that. So this dot chain length -1 because it starts from 0, so that's why we are doing -1. Okay, get latest block is done. Now what if you would like to add a new block in the blockchain, new data? Okay, so how we are going to do that? So add block, then like this, new block. Okay, so new block is equal to, so let me make you understand. So now you are adding another block. So for example, if blockchain already has three blocks, 0, 1, 2, where 0 is a genesis block. So now first, in order to add a new block, you need the hash value of the previous block and you need to assign to the new block. So that's what we are doing here. So new block dot previous hash is equal to this dot get latest block, means the last block's hash. So it's like this. Okay, very easy. Now that new block also has its own unique hash value, its own unique digital signature. So how we can create one? We already created a function to calculate hash, right? We are going to call that. So new block dot hash is equal to new block dot calculate hash. Simple. Now we are going to push that inside the chain. So this dot chain push new block. Okay, so it's very simple. Now we would also like to check if anyone changed my data or not. Let's say if you have entered something and any member of the staff has changed the data, you would like to validate that. How you can do that? So is, so first like check if the blockchain is valid or not, right? This is what we would like to see. So is chain valid is the function for let I is equal to 1. It will start from block 1 less than this dot chain. You are going to get length of it I plus plus, because 0 is the genesis block. So you will start comparing from 1 because it will check the hash value of the previous block, like that. So current you compare with previous, like that. Const current, as I've said, this dot chain. So so it means it will start from 1. Const previous is equal to this dot chain I minus 1, means if you are at 1 it will compare it with 0. If you are at 2 it will compare it with 1. It will run a loop like that throughout the blockchain. Now we are going to put a condition here. If current hash is not equal to current calculate hash, okay, whatever the hash value which current block has, if someone changed the data, we are going to compare with that updated calculated hash, and if it doesn't match, we are going to return false, right? So return false, like this. Okay, so this checks if the stored hash of the current block is still valid or not, because if someone make modification then it changes. Another check which we are going to implement here, which is checking if the previous hash field in the current block matches the hash of the previous block or not, right? So current dot hash, right? No, sorry, current dot previous hash is not equal to previous hash. Okay, if it doesn't match, that means modification has been made in the data and it will return true. Okay, like this. Just a second. Yeah, like this. Okay, now we will see how exactly we can create instance of blockchain class, and we can add new blocks. Let's say if we are making modification, what it is returning. We are going to make all of the experiments now. So let's first create instance, right? So how you can create instance of a class? So you can access all the methods which has been implemented within that specific blockchain class. So const mychain, you can keep any name, whatever you are preferable with. Blockchain, like this. When you write this, it automatically creates genesis block. At this point of time, when you create an instance, it has already created block 0, which is the first block of the blockchain. Now let's say I would like to add block, right? So how you can do that? Like this add block method, which we have implemented here in the blockchain class. You can easily access that method. New block like this. Now simply you pass the data index 1, because 0 is the genesis block which has been created already. Now the current date and time, now like this date.now to string, so we can easily read the date and time, and the data, so which is the transactions which has been made, so amount is 100. Okay, that's it. Now my chain again repeats same value, it's the second data, date and time, and the value is 200. And now we are going to print this specific blockchain and see whatever data it consists of. Okay, so console.log json.stringify my chain null. Okay, so we are going to print that. Now we are going to print blockchain json.stringify same, so we can read data easily what we would like to print. Now this one second value will be null. Why? Because we don't want any kind of filter, right? And to make it to give a space between two objects, so readability will be good, right? Now we are going to see the blockchain is valid or not, because we have already implemented that function, because we have already implemented that method. So is blockchain valid? Okay, we will print this my chain and call that method is chain valid like this. Okay, and done. Now we are going to run this program now and see whether chain is valid or not, and whether our data has been inserted or not, right? So how you can run it? Like this, node blockchain.js and press enter. Okay, so how we will do it? So let's analyze this. You can see here it's the index 0, which is the genesis block, right? So what exactly genesis block means? It's the first block of the chain, and the previous hash of genesis block will be always 0 because there is no previous block, and the hash value will be uniquely calculated using crypto-js library. Now let's move towards index 1. Here data was genesis block. Here we have stored amount 100, for example $100, 100 rupee transaction, anything. Here you can see previous hash value, that means the hash value of the index 0 block. If you compare these two, it's the same. If you compare index 2 previous hash with the hash value of index 1, it will be the same. And whether this blockchain is valid or not, so it is saying true. Why? Because we haven't made any modification. So now let's say if I would like to make modification in the data which someone has stored, right? Let's try that, what is happening. So let's do that. So let's say if you'd like to make a modification here, so how you can do that? My chain at which block you would like to make modification. For example, let's take index 1, right? Then dot which field, data equal to amount, you would like to change it to 300 instead of 100. Now let's run that code again. Node blockchain.js, press enter, and now you see initially it was true because blockchain was valid. Now you made modification and the blockchain is now not valid, it is returning false. Why? Because there is no issue with genesis block, because we haven't made any changes in that block, so hash value of that is unchanged. But you have made modification in index 1, so the hash value of index 1 block, there is a change and modification. So from now onwards in the previous hash value of this block is not the same as the hash value of the index 1 block. So there is a mismatch, and if there is a mismatch, it is going to be continue index 2, index 3, index 4, so whole chain become invalid. And this is how you can detect a modification in the blockchain. So it's a really very secure mechanism using which you can store your data as well, and you can easily implement your blockchain for your own applications and use cases. Thank you guys for watching this video. If you got some sort of value from this video, please let me know in the comment section below. See you in the next video. Till then, keep learning, keep hustling.